Hi guys, so the second video for today we're going to have a quick look at recurrence relations. These sound and look much more complicated than they actually are. All a recurrence relation is that basically to work out what the next term in the sequence is, so +1, that's the next one, you have to perform some sort of function on the previous term. So let's have a look at an example. So here we have our first example. It's telling us that in order for you to get the next term, so +1, you need to use the previous term that you had, and then what you need to do to that term is add on 4. That's the function that you're using. So they're telling you that the first term is 7. So if I wanted the second term, I'm going to call that U2, not the band. And to get that, I would need to use the previous term, which in this case would be U1, and add on 4. We know that U1 was 7, so I'm going to substitute that in. So 7 plus 4 gives me 11. And that's it. Then I want to find the third term. So U3 would be the previous term, which was U2. Again, not the band. Plus 4. So that's going to be 11, because that was our second term. Plus 4, so that gives me an answer there of 15. The question asked me to find the first 4 terms, so if I want to find U4, oops, wrong one. That would be U3 plus 4, which you could see is 15 plus 4, and that will give us an answer then of 19. So that's the basics of it. So our terms in order are 7, 11, 15 and 19. A question could go further to sort of say, find the sum of the series, or, some sort of work to do with an arithmetic sequence, but that's just the basics of a recurrence relation. So to take it into a problem-solving question, here we go. It looks more complicated than it is, so don't worry. So A1, which is our first term, is equivalent to P. My recurrence relation tells me that if I want to get to the next term in the sequence, I must take the previous term, square it, and subtract 1. Okay, a few extra little bits of information here. The number of the sequence has got to be greater than or equal to 1. Well, that makes sense because you can't get minus 5th term in the sequence. That, doesn't work. But the other piece of information here in the question that we should pay attention to is that the fact that P is less than 0. And with there being a squared and a bit of information there about something being less than 0, I envisage we're going to be taking a square root at some point. But let's not get ahead of ourselves. So question A, show that A3, so that would be the third term in this recurrence relation, is equivalent to P to the power of 4 minus 2P squared. So let's have a look at that to begin with. So I've just written out some information here that I know I'm going to need to use. So the recurrence relation and the first term. So let's have a look at what the second term would be. So A2 would be the previous term, which is P, all squared, and then subtract 1. So that makes my second term P squared minus 1. For my third term, A cubed, I would need to take my previous term, which in this case now is all of that, so P squared minus 1, all squared, subtract 1. So the cubed one is going to give me, so if I expand that bracket, remember that when we square it, it will look like this. So I will get P to the power of 4 minus P squared plus 1, and then I've got this minus 1 at the end. And I would suggest that you do need to show that line of workings out. So P to the power of 4 minus 2P squared. I have now successfully answered the first question to show that the third term would be equivalent to P squared minus 2P squared. Okay, the second question said that given that the second term, A2 is equal to 0, find the value of P. So I already worked out an expression for the second term, see my previous answer to part A. And all I'm going to do now is make that equal to 0. So P squared minus 1 is equal to 0. P squared is equal to 1. Taking the positive and negative square root of 1 there, Okay, not forgetting the cat, meow. So we are going to take, in this case, P is equivalent to -1. And if you remember right back at the beginning, that's because it said that the value of P is less than 0. So we know from that information, if I've got to choose between +1 and -1, it's going to be that P is -1. Okay, so here is the next part of the question. It's asking you to find the sum of the first 200 terms beginning from the first term for this sequence that you've been given. So on the side I've written out here a couple of pieces of information. So we know that A1 was equal to P, and we worked out in the previous part of the question that P is equivalent to -1. So our first term is in fact -1. Our second term is -1 squared, which is 1, take away 1, and that's 0. I mean, we were told that on the last part, but no harm in doing it again. And then for the final one, -1 to the power of 4, take away 2 times by -1 all squared. So that's going to give me 1 take away 2, basically. So we've got there -1. Now, if we have a look at what is happening here, we've got -1 to 0, back to -1. And it's just alternating. So I imagine the next one's going to be 0, the next one's going to be -1, the next one's going to be 0, the next one's going to be -1, 0, -1. So if we consider what will happen if I want to find the sum of 200 terms, with 200 terms, I will have 100 lots of -1 and 100 lots of 0. So if I take those, that will give me -100, that will give me 0, and so the sum of the first 200 terms would be -100. Obviously, if it had produced a geometric sequence, I would have used the sum for the geometric series, and if it had produced an arithmetic sequence, I would have used the sum for an arithmetic series. But here, I think, you just got to be a little bit on the ball and sort of notice what's happening with those terms. It's not geometric or arithmetic. Thanks very much.